All right, good evening, everybody. Welcome to today's lesson. How are we doing tonight? I said, how are we doing tonight? Boy, you guys are even quieter than normal tonight. Huh. Well, anyway, so we're going to do a little bit of factoring here. And so far we've done in this unit, we've done a little bit of factoring greatest common factors, finding something that goes into each term and taking that out. And we did a little bit of factoring by grouping a couple days ago. So factoring by grouping, you'll see down at the bottom there. We'll go through one more example of that to make sure we remember how to do that. And I also want to go through a couple examples of things that we did in the last unit. Remember we did perfect square trinomials and difference of perfect squares? And what that's going to allow us to do here is take these three trinomials that you see here at the very top, sorry, these two trinomials and this binomial, I should say. And we're going to factor those using our perfect square trinomial and our difference of perfect square techniques. So the idea is this first one, it's a perfect square trinomial, at least it might be. And what tells me it might be? What can I look at that and say, well, I think that's going to be a perfect square trinomial. Hopefully you're saying, well, it's the 9y squared, right? The 9y squared in the beginning, suggesting that's probably a perfect square. And the plus 16, that's definitely a perfect square, which means this is probably a perfect square trinomial. It doesn't have to be, but it's probably going to be one. And so we're going to make that assumption. We're going to try to factor this. We're going to try to split it back into that product of binomials that it started out as. And we're going to say that it is a binomial squared, and that fits our perfect square form. And I certainly could say it's that same binomial times itself. And so now we have to ask ourselves, if this is a perfect square trinomial, that means this fits the form a squared plus 2ab plus b squared, right? And if it's going to fit that form, and 9y squared was something squared, what did we square to get 9y squared? All right, you're a little quiet today, but I think I heard somebody say 3y, right? I think 3y is going to be the value. 3y times 3y gives you 9y squared. That should be good. And what do we square to get 16? We square 4, so we're going to put a positive 4 in the back here. That's what's going to give us our 16. And then we also need to make sure that that middle term, this 24y, we need to make sure that that came from 2ab. So what's a times b? 3y times positive 4 is going to give you a positive 12y. If we double that, we do indeed get 24y. So I know that 9y squared plus 24y plus 16 factors into 3y plus 4 squared, or 3y plus 4 times 3y plus 4. Everybody good so far? Okay, I'm going to have to assume that you are. So next one, difference of perfect squares. I told you we'd be seeing that over and over again, right? Here it is. We got difference of perfect squares. I know 64n squared is a perfect square. I know that 25 is a perfect square, and this little subtraction sign is a difference, therefore difference of perfect squares. So if this is a squared minus b squared, here's where we figure out what a is. If a squared is 64n squared, what is a? Hopefully you are saying that a is 8n. And remember, this is going to factor into a plus b, a minus b. So I'm going to need two sets of parentheses here. And 8n is going to go in both. And now what do we square to get 25? Hopefully you're saying 5 or agreeing with me that it's 5. And we're going to do it plus 5 and minus 5. So 8n plus 5, 8n minus 5, our a plus b right here. A minus b, when we multiply together, should give us a squared plus b squared. That is our product here. Everybody good so far? I'm going to hope we are. All right, so this next one, and this last one here. Again, I'm going to try to hopefully see if it's a perfect square trinomial. Is it? That's the question. So the first question is 4a squared a perfect square? Hopefully you are nodding. If the last one is also a perfect square, 49b squared, is that a perfect square? Hopefully you are saying yes. The fact that those both are means this is probably a perfect square trinomial. Again, that middle term has to work out, but we'll double check that afterwards. Let's assume it is and go ahead and factor. So I'm going to set up my binomial square, and I'm going to plug in the necessary pieces. So what did we square to get our 4a squared right over here? 2a will be the value that we square. And what did we square to get 49b squared? Hopefully we need a 7 to get the 49. Hopefully we recognize that we also need a b to get the b squared. So it's going to be a 7b. And our middle term is positive 28ab. That means that this is going to have to be a plus in here. And we'll double check and make sure that middle term does work out. What's 2a times 7b? That would be 14ab. If we double that, we do get 28ab. Everybody good so far? Okay, so that's going to allow us to do some factoring using the fact that we have some perfect square trinomials there, or our difference of perfect squares example right up here. All right, so real quick little recap of what we did the other day, factoring by grouping. Remember we said that if there is nothing that goes into all terms, but there's an even number of terms, then we can sort of group those into two sets. And we've got the first pair and the second pair, and we want to see if we can factor something out of each pair. Our first pair, mx plus my, hopefully we recognize that there is a common m in both. Hopefully we recognize over here that there is a common d, but not only that, we also actually have a subtraction sign in front of each, which we can interpret as a negative. So this is actually a negative d in both that we're going to take out. And that's our second step of factoring by grouping. We're going to factor out of each pair. From the first, I factor out the m. From the second, I factor out the negative d. And we end up with, again, that common binomial. I got an x plus y. Since I have that x plus y on both of these polynomials, we can factor that out to the front, which will leave our m minus d inside the parentheses right down here. So again, our x plus y was on both of these. We were able to factor that out to the front, which left m minus d. Everybody okay with that so far? That is just a little recap of factoring by grouping. Okay, so let's get into the meat of today's lesson here. So factoring trinomials of the form x squared plus bx plus c, where b and c are some numbers. And the key thing here, the key thing I'm stressing with today, at least for today, we're going to be factoring things that are just a variable squared in the beginning, meaning there's no coefficient. There's no number in front of the x squared term. So something like x squared plus 9x plus 18, this would be a trinomial that we can factor using this method. Okay? So I want to do a real quick little recap here of FOIL, right? When we're multiplying two binomials together, typically we use FOIL. So a product of our first terms, x squared. Product of our outer terms would be bx, that's over here. Product of the inner terms is ax, that's right here. And then our product of our last terms, ab, gives us our product over here. And we've done that many times, so that should be pretty familiar to you by now. And the idea is that normally these middle two terms are going to be like terms. Not always, but most of the time. And we're going to be able to combine those two. So if I look at this trinomial, most likely this positive 9x came from our inner and outer terms being added together. So one of these was our ax, one of these was our bx. And this last term, 18, is ab. It's the product of a times b. So hopefully we can start to recognize that I've got a product ab here, and I also have the a here and b there. That's going to help us factor this. Because I know right away the fact that there's no coefficient in front, and that's why this method's going to work here. The fact that there's no coefficient in front, and I just have an x squared, means what has to be at the beginning of each of these. If x squared is the product of my first terms, what better be in each one? Did you say x? I hope you said x. If you didn't, well, it's x. So we're going to have to place an x in both. So an x goes here, and an x goes here. That way the product of the first terms gives me my x squared over here. Okay? Now the 18. The 18 is some a times b. It's the product of these last two terms. I want to figure out what those last two terms are. Now, two things that multiply to give you 18, you've got some choices, right? But you also notice up here that one of them is going to be ax, the other is going to be bx. They have to add up to positive 9x. Which means not only do I want two things that multiply to make 18, but also two things that add up to positive 9. So what kinds of things give you 18? Well, 1 and 18 would give me 18, 2 and 9 would give me 18, 3 and 6 would give me 18, and certainly lots of decimal and fractional values, but for the most part here we're going to be looking at integer values. Which of those add up to 9? So let me list them out here. 1 and 18. Ooh, hold on. Did I write that correctly? 1 and 18, 2 and 9, 3 and 6. Hopefully we recognize right away that 3 and 6 are the ones that are going to add up to positive 9x. So we're going to place one in each. Positive 3, positive 6. And now if I take a look at foiling this out, here we get x squared. Our outer terms are 6x, inner term is 3x. That gives you the 9x. And 3 times 6 is going to give you 18 as well. Look all right? Good so far? Okay. Let's try this one, and try this one on your own. So what I want you to do is pause the video, try to factor this. Shouldn't be too bad. and then come back and check your answer with me. So go ahead and pause it and work through the problem. I will wait. Did you do it? Hopefully you did. You're not waiting for me to do it for you, are you? Pause it. Come on, you can do it. Okay, so let's take a look. So we want our first terms to give me m squared. So what's got to be in the beginning of each? It's going to have to be an m and an m. That way I get m squared. And I want two things that multiply to give me 12 that add up to negative 8. Again, lots of things are going to multiply to give me 12. Since they're going to add up to negative 8, they're both going to have to be negative, so I get a positive 12 here. So let's see, 3 and 4 don't work. That gives you 7. 2 and 6 give you 8. And again, I need a negative 8, so I'm going to need a negative 2 and a negative 6. So minus 2, minus 6. And if I check that FOIL real quick, m times m is m squared. Outer term's negative 6m, inner term's negative 2m. That's the negative 8m. Last term's a negative 2 times a negative 6 give me positive 12. And we've got that factored nicely. Good so far? All right. You ready to try the next one on your own? I hope you are. Okay, so let's try this one. You got a squared minus 6ab minus 16b squared. Go ahead and try to factor that. So go ahead and pause it. Factor that. Shouldn't take more than a minute or two. And then come on back. Just pause it. Did you do it? Good. Good for you. If you didn't, bad for you. Okay, let's take a look. So again, we want to factor this. Again, it's going to have to be a squared in the beginning. I have first terms, a times a gives me a squared. That's nice and easy. Then the last terms need to multiply to give me negative 16. They need to add to give me a negative 6. Now I also have a b squared at the back. And I know there's got to be something back here that's going to give me b squared. That part is easy. That part's just going to give me a b. And all you really need to do is just place a b in both. So that's going to end with a b. That's going to end with a b. And now I just need to figure out what two factors of negative 16 give me negative 6. So we've got, let's see, 4 and 4, that's not going to work. 1 and 16 is not going to work. 2 and 8, oh, 2 and 8. Oh, 2 and 8 are going to be able to give me 6, right? Which one's got to be negative? Which one has to be positive? If I want a negative 6, does the 2 have to be negative or does the 8 have to be negative? Hopefully we're all agreeing that 8 has to be negative. A negative 8 and a positive 2 give me a negative 6. We place one in each. Does order matter when you're multiplying? Of course not. So we can place either one either place. So I'm going to do a plus 2b and a minus 8b. And now we have that very nicely factored. Everybody okay? Okay, excellent. Good for you guys. We are going to stop the lesson at this point. I hope you got a lot out of that. I know I certainly did. All right, have a good one, guys.